Ever wonder if, like, maybe there's a different path to more powerful AI, not just, building bigger and bigger models,
Right.
but like finding ways to make them think smarter,
Yeah.
when it actually matters.
Yeah, that's a fascinating question. And actually there's some really cool research that just came out from DeepSeek and Tsinghua University that really dives into that idea.
Oh, great.
And they're exploring this concept called inference-time scaling for what they call generalist reward modeling.
Okay.
And it sounds complicated, but essentially they're trying to find ways to make AI better at reasoning in those moments. Those key moments when it's actually generating a response.
I see. I see. So how does that even work? Like, what's the core problem they're trying to solve here?
Well, you know how we've talked about how important it is to be able to accurately evaluate an AI's output, right? Like especially when you're dealing with these large language models, these
Yeah.
LLM.
Yeah, definitely. Like, you need to be able to tell if it's actually reasoning well or just kind of, spitting out something that sounds plausible.
Exactly. And that's actually really tricky, especially in areas where there isn't like a single right answer.
Right, right.
Like how do you reward nuanced thought? How do you measure something like that?
Okay. Yeah, that makes sense.
Yeah, okay.
So if you can't even like accurately judge how well an AI is reasoning, how can you really fine tune it to get better?
Precisely. And that's where this idea of reward modeling comes in, right? So, you've got reinforcement learning RL, where you're basically giving the model feedback to guide its learning.
Right, like training a pet with treats.
Exactly. You give it a treat when it does something good, you correct it when it does something wrong.
Yeah.
But in these really broad general knowledge domains where, the AI is trying to reason about all sorts of things,
Right.
figuring out what the right reward is can be incredibly difficult.
I see. So is DeepSeek's answer to this like just throwing more data at the problem?
Not really. I mean, obviously data is important, but their solution is much more clever than that. It's actually a three-pronged approach.
Okay, for three-pronged approach. I like it. So what are these three prongs?
So prong number one is what they call the point-wise generative reward model, or GRM for short.
GRM. Okay, got it.
Prong number two is a new training technique called self-principled critique tuning, or SPCT.
SPCT. All right, keeping track.
And then finally, the third prong is inference-time scaling, which is where they actually run the model multiple times in parallel and use a meta RM to kind of like oversee everything.
Whoa, okay, lots to unpack there. Let's start with the GRM. What is that all about?
Okay, so the key idea with the GRM is that instead of just giving a simple score, like, a number out of 10 or a thumbs up or thumbs down,
Well,
the model actually generates a critique that explains why it's giving that score.
oh, interesting. So it's like giving feedback like a teacher would instead of just a grade.
Exactly. So for
Huh.
example, it might say something like answer 1 is logically clearer but lacks detail. Final score 8, 6 out of 10.
Okay, so it's giving
Yeah.
more context, more nuance to the evaluation.
Right. And that's really important because it gives you a much richer understanding of the model's reasoning process. You're not just getting a number, you're getting an explanation.
That makes sense. So the GRM gives us the why behind the score. Now, what about SPCT? Self-principled critique tuning. That sounds like it's all about making those critiques better.
You got it. So the researchers realized that if you give the reward model good evaluation principles to work with, its scoring quality improves significantly.
Interesting. So it's like you're giving the model a rubric to follow.
Yeah, exactly. Like if you're grading an essay, you'd want to have clear criteria for what makes a good essay, right?
Right, of
They
course.
might have principles like, logical coherence, 35% importance, or information completeness, 20% importance, things like that.
I see. So it's about teaching the model how to evaluate well. But like, how does that actually happen? How do you train it to use these principles?
So they do it in two phases. The first phase is called rejective fine-tuning, or RFT. This is like the initial setup where they fine-tune the GRM to generate those critiques and evaluation principles in the right format,
Okay.
and also to kind of weed out any really bad evaluations right from the start.
So that's like the warm-up.
The basics. Exactly. And then the main event is online RL. This is where things get really interesting because now the GRM starts to learn to generate its own evaluation principles and critiques in real time.
Whoa, hold on. So it's not just using those preset principles anymore.
No, it's actually learning to come up with its own criteria for what makes a good answer.
That's wild. So it's like it's developing its own sense of judgment.
Yeah, and they use some basic preset rules to kind of guide this process, right? Like to
Yeah.
give feedback to the GRM on how well its evaluations are aligning with actual human preferences.
Right, right. So it's not just going off the rails completely.
Exactly, but it is learning to think like a good valuator.
Okay, I'm
Yeah.
starting to see how this all ties together.
Yeah.
So how does this lead to that inference time scaling you mentioned?
Right, so this is where they leverage the GRM's ability to generate these really diverse evaluations. So during inference, when you're actually using the model to, generate text or answer questions,
Mm-hmm.
they do something called parallel sampling, which means they have the GRM generate multiple different sets of principles plus evaluation plus score for the same question and answer.
Oh, so it's like getting multiple opinions from the same model.
Exactly. It's like asking the model to evaluate its own reasoning from a few different angles, using slightly different rubrics each time.
I see. So instead of just one evaluation, you're getting several, and each one might be based on a slightly different set of criteria.
Precisely. And then to get a more reliable final reward, they combine these multiple evaluations, maybe through like a simple vote or by adding up the
So it's
scores.
like a more holistic assessment.
Exactly. And the key takeaway here is that we can actually squeeze more performance out of the same model just by making it think in parallel and then comparing its different lines of reasoning.
I see. I see. And you also mentioned this meta RM, this referee of referees.
Yeah.
What's its role in all of this?
Right. So because the GRM is generating all these different evaluation frameworks, some of them might be better than others, right?
Sure.
So the meta RM is basically a quality control system. It's a separate model that's trained to assess the quality of those principal plus evaluation pairs.
So it's like a supervisor checking the work of the evaluators.
Exactly.
Yeah.
And then it can filter out the evaluations that are, maybe less insightful or less reliable, or it can give more weight to the really good ones during that aggregation process.
So it's ensuring that the final reward is based on the most sound reasoning.
Exactly. It's all about refining that feedback loop.
Okay, so this is all super interesting, but like what happened when they actually put this whole system to the test?
Well, the results were pretty amazing.
Okay, tell me more.
Their DeepSeek GRM, which was built on the Gemma 227B model, actually outperformed existing reward modeling methods by a significant margin across various benchmarks.
Wow, so it actually worked.
It did. And what's even more impressive is that it performed on par with much larger proprietary models like Nematron 4 340B and GBE40.
So they're getting comparable performance with a smaller model.
Exactly. Which is huge because it means you don't necessarily need these massive resource-intensive models to achieve really good results.
Right, right. So it's like brain over brawn.
Exactly. And they also found that as they increased the number of samples they took during inference, the performance of DeepSeek GRM improved much more rapidly than other models.
So that inference time scaling really makes a difference.
Absolutely. But the real shocker was when they compared it to their own massive model.
Oh, right. You mentioned that. So what happened there?
So on the reward bench dataset, their 27 billion parameter DeepSeek GRM using Inference-Time Scaling with 32 samples, and the Meta RM actually achieved performance that was comparable to, and in some cases even surpassed, the zero-shot performance of DeepSeek's own 671 billion parameter mixture of experts model.
Wow. That's a huge difference in size.
It is, and it really highlights the power of this approach. They're essentially getting similar or even better performance with a much smaller model just by having it think more thoroughly at inference time.
That's incredible. So you could potentially get like top-tier AI performance without needing these enormous models.
That's the exciting potential, and it has huge implications for things like, cost and accessibility.
For sure, for sure. So it sounds like this GRM with the SPCT and the inference time scaling is really a game changer.
It could be. And they also found some other interesting things, like, for instance, the GRM showed much more consistent performance across different types of tasks.
Oh, interesting.
And it also exhibited less bias compared to more traditional reward models that just output a single score.
So it's more robust and more fair.
Exactly, it
Right.
seems to be. And their experiments also confirmed that both the principal generation and the online learning aspects of SPCT were critical to its success.
So that two-phase training method really matters.
It does. And interestingly, even without that initial RFT phase, the online RL part alone provided a significant performance boost.
So the model really benefits from learning its own evaluation strategies.
It seems so.
Wow, this is all really fascinating stuff. It sounds like DeepSeek has really made some groundbreaking progress here.
I think so. And it really raises some interesting questions about the future of AI.
Like what?
Well, we've always kind of assumed that bigger models are better, right?
Right, more parameters, more power.
But this research suggests that maybe there's a different path. Maybe the key to more intelligent AI isn't just about building bigger and bigger models, but about finding smarter ways to architect and utilize the systems we already have.
Right, so like maybe it's not just about the size of the brain, but about how you use it.
Exactly. And it makes you wonder what new possibilities could emerge if smaller, more accessible models could genuinely rival or even surpass the capabilities of their giant counterparts just by thinking more deeply when it counts.
That's a really cool thought. It kind of changes the whole game.
Mm.
It does.
Yeah.
And it'll be interesting to see where this research leads in the coming years.
Definitely. It's exciting to think about all the potential applications.
For sure. This could be a real turning point in the field of AI.
Well, thanks for breaking all of this down for us. It's been a really enlightening conversation.
My pleasure. It's always fun to dive into these cutting-edge topics.
Absolutely. All right, well, that's all the time we have for today, but we'll be back next week with another deep dive into the world of AI, so stay tuned.
See you then.